In this video, we're going to look at how sound waves can travel through materials and see how this allows us to hear things. Sound waves are really just vibrations that pass through the molecules of a medium. And as sound waves are a type of a longitudinal wave, they travel as a series of compressions and rarefactions. Compressions are the regions where the vibrating particles are closest together, so all bunched up. Whereas rarefactions are the regions in between, where the particles are furthest apart, so all spread out. It's kind of weird to explain, but when sound waves travel through a solid, they do so by causing particles inside that solid to vibrate. And those vibrating particles will then collide with their neighbours and pass on the vibrations. And as this happens over and over again, the sound wave gets transmitted through the material. Because sound waves need particles to be transmitted, the more densely packed the particles are, the faster the sound travels. This is why sound travels faster in solids than in liquids, and slowest of all in gases. It also explains why sound can't travel at all through a vacuum, because there are literally no particles for the sound to vibrate through. Now, one really important point is that as sound waves pass between different mediums and speed up or slow down, their frequency doesn't change. The reason this is really important is because if we look at the speed equals frequency times wavelength equation, we can see that if speed is increasing, but the frequency remains the same, then the wavelength must increase instead. So the point to remember is that the wavelength gets longer as sound speeds up, which happens in higher density mediums like solids, whereas the wavelength will get shorter as the sound slows down in low density materials like air. The fact that sound changes speed as it moves from one medium to another means that sound can be refracted, just like light can. Sound can also be reflected and absorbed, with hard flat surfaces reflecting most, which is what gives us echoes.